Hi everyone, I'm Nicole with Estes Education. Today, we're going to learn about Newton's 3 laws of motion and how they help rockets like this one fly into the sky. Let's start with Newton's first law. An object at rest stays at rest, and an object in motion stays in motion unless acted on by an unbalanced force. Consider this cool Hot Wheels car. It won't move until you push it, but once you do, it will continue moving until something slows it down, like friction, or it runs into something. Now, how does this apply to rockets? A rocket sitting on the launch pad won't move at first because there are no unbalanced forces acting on it. But when we ignite the engine, the force of thrust pushes the rocket up, overcoming gravity, causing it to move up. The other place we can see Newton's first law with rockets is when they're coasting up to apogee. So once the propellant in the engine burns out, the rocket is in motion and continues in motion until gravity and drag slow it down. Fun fact, NASA's DART mission is a great example of Newton's first law. NASA wanted to see if it could successfully alter the orbit of an asteroid as a sort of test for our planetary defense. In 2022, NASA crashed a spacecraft into the asteroid Dimorphos, which orbits a larger asteroid named Didymos. And it did alter the orbit of Dimorphos. Before the crash, Dimorphos was continuing its motion until acted on by an outside force, the DART spacecraft. Newton's second law is next. Force is equal to mass times acceleration, or F equals ma. Imagine trying to push this tiny Hot Wheels car versus moving this heavy box. The heavy box takes a lot more effort or force to get it moving, right? That's Newton's second law. In rocketry, this means that the greater the force or thrust from the engines, the faster it accelerates. Newton's second law also tells us that the more massive the vehicle, like the SLS, will require a much larger engine with more force to get it moving compared to a smaller rocket like this. Fun fact, while I can't push this Hot Wheels car too fast with my hand, a real race car can reach top speeds of over 230 miles an hour. But compare that to the SLS, which can reach speeds of up to 22,000 miles an hour. And finally, we have Newton's third law. Every action has an equal and opposite reaction. A fun example is a person jumping off a diving board. They push down onto the board pushes up back on them, launching them into the air. In rocketry, the action is the gases from the engine pushing downward, and the reaction is the force that pushes the rocket up. This is how rockets launch into the sky. So, to recap, Newton's first law explains how rockets stay on the pad until the engine ignites, and why they continue to coast until slowed down by gravity and drag. Newton's second law explains the relationship between the force of the engine, the mass of the rocket, and the rocket's acceleration. And Newton's third law explains how the gases pushing down are able to launch the rocket up into the sky. Thanks for learning about Newton's 3 laws of motion with me today. Check out this rocket launch to see the 3 laws in action. And if you like this video, like, subscribe, and hit the bell to be alerted for new content. See you next time.